Okay, everyone. Hello and assalamu alaikum. We are starting with our today's session. So in this particular session, we will be doing two papers, difficult questions from two papers, November 2021, paper 5.2, and November 2021, paper 5.3. These are the two papers that we will be looking at. We'll be looking at difficult questions from these two papers, okay? So make sure that you have responded to the polls that I've posted. And let me know. Please have a look at the polls and let me know the questions that you find difficult from these two papers. So we can have a look at those questions in particular. So we're starting from this one. This is paper 5.2 from this session, November 2022. Sorry, 2021, not 2022, November 2021, paper 5.2 from this session. And the second paper that we want to do is 5.3 from the same session. All right, let's begin with this. So let me have a look at the polls that I posted and see the questions that you asked from these papers. Okay, so first of all, from this paper, we have question number 2. Okay, so first question, you say you don't have any problem. Remember the condition for independent events? Probability of A intersection B. That has to equal probability of A into probability of B. You'll have to check this. If the condition satisfies, that means they are independent. Otherwise, they're not. Okay, so none of you have asked about it. So I'll just skip that. Okay, so this is the first question that you guys have asked about. Question number 2 from this paper. Okay, so it says a group of 6 people is to be chosen from 4 men and 11 women. Okay. In how many different ways can a group of 6 be chosen if it must contain exactly 1 man? 6 people are to be chosen from 15 people. Now, if you need to have it exactly 1 man, what are the possible cases you can have for this? Let's think about that. So we have some men. There are 4 men. We have some women. There are, in fact, since we want exactly 1 man, it's not going to be that complicated. We don't have many cases here. Out of 4 men, we can just select 1. So that will be 4C1. And out of the 11 women, we have to select the remaining people then. There's only 1 case, in fact. 6 people was the total that we had to select. If we have 1 man, we need 5 women. And that's going to give you the result. 4C1 into 11C5. You can see what that turns out to be. What's the result that we get from this? 11C5 into 4C1. Okay, 1848. 1848. That's the answer that we get. Okay, that's the first part. Now it says 2 of the 11 women are sisters. The sisters are Jane and Kate. In how many different ways can a group of 6 be chosen if they cannot both be in the group? Okay, so you don't want both of them in the group. You can have one of them, but not both. Now, in how many ways can you do this? What you can do is you can find the total number of ways of selecting those 6 people such that you don't have any conditions. And then from that, you subtract the case where you have both of those sisters selected. Okay. Do we have any condition for selecting those people? Well, as in the number of men and women that we have to select? No. We have 15 people in total. Out of those 15 people, how many do we need to select? Out of those 15 people, we need to select 6 people. So what we can do is we can say the total number of ways, if we had no restrictions, what would that be? That would be 15C6. If we had no restrictions, okay? Out of 15 people, we had to select 6. That's just 15C6. Now from this, we subtract the case when both the sisters are selected, because the remaining cases will be when both of them are not selected. When either one is selected or the other is selected or none is selected, all of them will be accounted for. So when are both selected? If both the women are already selected, so what we're doing is total minus both sisters selected. And that will give us the result. Now, if both sisters are already selected, what was the total number of people that we had? 15. How many people are we left with? 13. Out of the remaining 13 people now, we need to select how many more? We need to select 4 more people. Earlier, it was 6 out of 15, but if 2 people are already chosen, the 2 sisters are already chosen, what are the people that we have choice about? The remaining 13 people. Out of the remaining 13 people, we have to choose 4. That's 13C4. So if we subtract this number from the total, that is going to give us the result. You can see what that turns out to be. 15C6 minus 13C4. And that's giving me 4290. And that's the final result here, 4290. Okay? Yes, Delmi, I'll do that. Is that an S1 question? Or is that something else? We'll have a look at that. Okay, all right. We'll have a look at that at the end. All right. Okay, this is part B. And that's it. That was pretty straightforward. No? Why did so many of you ask about this? Okay. So that was pretty straightforward, this question. Okay, question number 3. A bag contains 5 yellow and 4 green marbles. None of you have asked about it. I think what all of you are doing is you're just looking at the questions. Okay, it's a permutation combination question. It should be difficult. And then some of the other questions that are actually difficult, you skip, you miss out on them. Okay, so 3 marbles are selected at random. What's the probability that exactly one of the marbles is yellow? We need to show that this probability is 5/14. Okay, that's the first part. You have to draw a probability distribution table for this. You have to find expected value of x. Now, I'll just do the first part for you. You can do the rest of them then, because this is a standard method that you need to use for problems like these. If you have 5 yellow and green 4 marbles, 3 are selected at random, and they're not replaced. Okay, you're not replacing the marbles. What's the probability that exactly one of the marbles is yellow? Probability. Now, if there was no restriction, what would be the number of ways of selecting 3 marbles out of these 9 marbles? It would be 9C3. So you can say the total number of ways where there are no restrictions, that's 9C3. What's the probability that exactly one of them is yellow? What's that probability? Out of 5, that means we have to select 1, right? Out of 5 yellow, we need to have 1. And out of 4 green, we need to have 2. And that's going to give you this probability. Okay, you can see what that turns out to be. 5C1 into 4C2 divided by 9C3. What's that? 5/14. Okay, so this is 5/14. All right. Now you do the same thing for the second part. X represents the number of yellow marbles selected. Now what could be the possible values of X? That could be 0, 1, 2, 3. You would do 5C0 and then 4C3 for X equals 0. Then 5C2 into 4C1 and then 5C3 into 4C0. Okay, you can do that second part and then expected value of X, use the formula for expected value. The second and third parts, once you understand how to do the first part, the rest of it is fairly straightforward. Okay, let's move on to the next one. Question number 4, and let's have a look at that. If that, again, that's an arrangement question. Let me see if it's actually difficult. Exactly 2 letters. Okay, so it's slightly different from the standard problem. So let's have a look at this. In how many different ways? Question number 4. In how many different ways can we arrange the 9 letters of the word telescope? There are 9 letters. That's 9 factorial. But then how many of them are repeated? E, E, E. There are 3 E's. That's 3 factorial. Any other repeated letter? No. No other letter is repeated. That's 9 factorial over 3 factorial. You can see what this turns out to be. That's the first part. Pretty straightforward. Evaluate this and see what that gives you. That's 60483. Okay. Okay, let me go back there. Okay, so it says exactly one of the marbles is yellow. We need to find probability for that. What's probability? One way to think about probability is number of favorable outcomes divided by the total number of possible outcomes. What's the total possible outcomes such that we don't have any restriction? We have 9 marbles. We have to select 3 of them. That's 9C3. That's your denominator. Okay. And then in the numerator, we have the number of favorable outcomes. They want exactly one of the marbles to be yellow out of 3. So that means there has to be 1 yellow and 2 green. So out of 5 yellow, we choose 1 yellow. Out of 4 green, we choose 2 green. So this is for yellow marbles, this is for green marbles. And that gives you the probability. Now, could you do it directly? You could do it another way as well. You could say, since you're selecting 3 marbles, the first time you select it, if you need to basically have 1 yellow and 2 green, right? That's what you want. 1 yellow and 2 green. Another way to think about this would be, the first time you select a marble, the probability of that being yellow is 5 over 9. Then what's the probability of selecting a green marble after that? Remember, this is without replacement. If you selected a yellow first, how many green do you still have? 4. But what's the total number? 8. And then another green, that will be 3 out of 7. However, the problem is this is just one possible path on the tree diagram. On your tree diagram, you could have Y, G, G. There are other paths that will give you 1 yellow and 2 green as well. For example, you could have green, yellow, green, and you could have green, green, yellow. There are 3 paths. How do you figure them out? In how many ways can you arrange this? 3 factorial over 2 factorial, because the G's are repeated. You multiply this by 3 factorial over 2 factorial, and that should give you the same result as well. Just like we did yesterday, right? A problem like this. You can do it both ways, combinations and thinking of a tree diagram like this. And that gives you the same result. That's 5 over 14. This would be the other way of thinking about this. Okay. All right. So you can do the rest of the parts of that. Let's have a look at this. Question number 4 now. We're done with part A. Now, what about part B? It says, in how many different ways can the 9 letters of the word telescope be arranged so that they are exactly 2 letters between the T and the C? You want exactly 2 letters between T and C. In how many ways can you do that? Let's think about this. Alman, just seeing your name reminded me that you actually sent me a message about an S1 problem. There was an M1 exam the next day, so I could not respond to that point. But I'll do that. Okay. I'll do that today, inshallah. All right. In how many different ways can the 9 letters of the word telescope be arranged so that there are exactly 2 letters between the T and the C? Okay. So it looks like this. So we can represent these 9 letters by these 9, but represent the 9 letters using these 9 boxes. Okay. Now what we want is, we want exactly 2 letters between the T and the C. Okay. So it's going to be like this. You have a 4-letter group that's moving together. And in that group, you need to have T on one side, C on the other side, and then some other 2 letters in the middle. Okay. Now, what we can do is, we can represent just one big box like this. We can merge 4 boxes. These are 9 boxes in total. Let's merge 4. And in those 4 boxes, we could put that box that has 4 letters. A T on one side, a C on the other side, and then in the middle here, we could have any of the other letters. Okay? Now, what are the remaining letters that you have? A T is gone, a C is gone. The remaining letters are E, E, E. There are 3 E's there. Then we have L, S, O, and P. Right? These are the remaining letters that we've got. Now, in how many ways can we arrange them? Now, one way to think about this is, think about these boxes. How many boxes do we have now? These boxes can move around, right? These boxes can move around. But the problem with that would be, we don't know where the E's are, so we don't know whether they're identical or not. So we can't actually think of it like this, because we don't know where the E's would be, because if they're here, we'd have to consider them differently. If they're there, we have to consider them differently. Okay. So what we can do is, we can think of it like this instead. We can say, okay, T and C, I'm going to look at it like this instead. This is one big box. Put T and C here, and then you have 2 letters in the middle. Now this box has to remain together. Okay, let's think of it like this instead. And that's going to make it simpler. This box has to move together. Now, first of all, let's think about the other letters, the remaining letters. We've got 1 letter here, another here, 3, 4, 5, 6, 7. These are the 7 remaining letters. In how many ways can we arrange these 7 letters? These are the 7 remaining letters. We've got 7 places for those 7 letters, right? In how many ways can we arrange those 7 letters? 7 factorial. However, 3 of them are identical, because you would have E's amongst these 7 letters. So we have to divide by 3 factorial because of that. Okay, so it's 7 factorial over 3 factorial. Make sense? Then you think about that this box can also move around. This box can go here, right? Such that you have 1 other box on the left side and then 4 boxes on the right side. That's another possibility. So this box can either be here in this current position, or it could go here. That's 2 cases in total until now. It could go here, 3, to go here, 4, 5, or 6. This box can change places. For example, one possibility that I've mentioned there is that you have one other box on the left and then 4 on the right. Another possibility is you have 2 boxes on the left of this big box and 3 boxes on the right. Another possibility is you have 3 on the left and 2 on the right, and then 1 on the right side and 4 on the left side. And then finally, all of them on the left side. That's 5 boxes on the left side. How many cases do we have? 1, 2, 3, 4, 5. These are the cases that I've represented up there. There are 6 ways for this big box to move around. So what we do for that is we multiply this by 6, right? This box can move around in 6 ways. All right. And then finally, I've put T here on the left side and I've put C here on the right side. They can also switch places with each other. We could have C on the left and T on the right. That's also possible. In how many ways can they switch places? T and C can switch places with each other in 2 ways as well, or 2 factorial ways. It's the same thing. So that's the number of ways for T and C to switch places with each other. And that should give you the result. You can see what that turns out to be. 7 factorial divided by 6 into 6 into 2. That is 10,080. This is the result that we get from this. This is one possible way of doing this. Is that okay? No problems? Okay, good. That's part B of this. All right. Let's look at the next one. So let me see what other questions they've asked about in this paper. Okay, question number 5 as well. Let's try this. It says in a certain region, the probability that any given day in October is wet is 0.16. So probability of any particular day being wet is 0.16 independently of other days. Find the probability that in a 10-day period in October, fewer than 3 days will be wet. Okay. Find the probability that in a 10-day period in October, fewer than 3 days will be wet. Now, what kind of distribution is this? This is 0.16 probability of a day being wet. They're talking about a 10-day period. That's a fixed n. You want fewer than 3 days to be wet. That means fewer than 3 successes. If we call a day being wet a success, right? You would say a given day in October being wet, we call this a success. What's the probability of success? It's 0.16. Probability of failure, 1 minus this, that's 0.84. N is 6, N is 10. That's a binomial distribution because we are looking for the number of successes. We want the number of successes to be less than 3. Fewer than 3 means less than 3. So what are we looking for? Probability of X being less than 3. That's what we want to find out. Now in binomial, we don't have a direct formula for any inequalities, right? We have to find the probability for each one of these cases separately. X equals 0, X equals 1, and X equals 2. And then add them up together. Remember, in binomial, we also have to consider X equals 0. In geometric, we don't consider X equals 0. We only consider X equals 1 onward, because in binomial, we can have 0 successes as well, right? It's possible that you have no successes. That's a possibility, okay? Now, you just apply a formula for this. What's the formula for binomial distribution? That's X equals R, probability of that is NCR, P raised to power R, 2 raised to power N minus R. Just apply that on each of them individually. You get 10C0 into P, which is 0.16, raised to power 0 into 0.84 raised to power 10 minus 0, which is 10, plus 10C1 into 0.16 raised to power 1 into 0.84 raised to power 9, plus 10C2 into 0.16 squared into 0.84 raised to power 8. Evaluate this and that will give you this probability. It's better to evaluate all of these terms separately. That saves you from careless errors. But you can do it all together as well, as long as you are sure about your calculation. What do we get from this? Anyone can do this? .794. Okay, so the result that we get from this is 0.794. That's the probability. Now it says find the probability that the first wet day in October is 8th October. Now, what's that? First success. What does that remind you of? Probability of getting your first success on a particular outcome, on a particular attempt, that is geometric distribution. Probability of getting your first success on a particular outcome, right? So again, the probability of success is the same as before, because again, we're calling a day being wet as success. So first success, that's what we're looking for. Probability that the first success comes on 8th of October. That means it comes on the 8th day of October. This is what we're looking for. What's the formula for geometric distribution? Probability of x equals r. That's 2 raised to power r minus 1 times p. This is input values there. Q is 0.84 raised to power 8 minus 1. That's 7 into p. That's 0.16. And that gives you the result. You can see what that turns out to be. 0.84 raised to power 7 into 0.16. That's 0.0472. Okay, so you need to remember what you are looking for in binomial. In binomial, you're looking for the probability of having a certain number of successes. In geometric, you're looking for the probability of the first success coming on a particular attempt. Okay, so note the difference between the two probabilities that you're looking for. In one case, you're looking for number of successes. In the other case, you're looking for the probability of getting your first success in a particular attempt. Let's look at the next one. It says for 4 randomly chosen years, find the probability that in exactly one of these years, the first wet day in October is 8th October. Okay, now understand the statement well. For 4 randomly chosen years, we're choosing 4 years. Out of those 4 years, we need to find the probability that in exactly one of them, the first wet day in October is 8th October. Now, what's the probability of the first wet day in October being 8th October? We find that above. That's 0.0472. In this case, if we call this a success, first day in October being wet is 8th October. What's the probability of that? If we call this a success, we say the probability of that is 0.0472. Okay, so in this case, we say this is how we are defining success. We are choosing 4 years. So n is 4. Out of those 4 years, what's the probability that exactly you get exactly one success? There's exactly 1 year out of those 4 years where the first wet day in October is 8th October. So what's the probability that you have exactly one success out of 4? Probability of success is 0.0472. What's the probability of failure? You do 1 minus this. That's doing 0.9528. Okay, that's the probability of failure. We want the probability of having exactly one success. What kind of distribution is that? That's binomial distribution. We're talking about number of successes, getting exactly one success. NCR, P raised to the power R, Q raised to the power N minus R, that will be 4C1 into 0.0472 raised to the power 1 into 0.9528 raised to the power 4 minus 1, which is 3, and that should give you the result. Let's see what that turns out to be. What do you get from this? 4 into 0.0472 into that's 0.1633, right? So you can say to 3 significant figures, that's 0.163. That's the result that we get from this. Can we just multiply probability of success and probability of failure raised to the power 3? You're saying, can we just do this thing? Well, that will be the probability that you have one success and 3 failures in one specific order, like this. So the first is a success, and then you have 3 failures. But you can have other possibilities as well. You also have to add those possibilities. You can also have F, S, F, F. You can also have F, F, S, F. You can also have F, 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 S. There are 4 cases like this. This 4C1 accounts for those 4 cases. There are 4 cases like this. We have to multiply that by 4. In this case, that's coming from 4C1. So we can't just do this part. Okay. All right, that's part C. Now let's move on to the next one. Okay, so what's the next question you've asked about? Okay, normal distribution. We don't have any problem with this. The first part is simple normal, and then you have inverse normal. Further taken to differs from the mean by less than 15 minutes. What would you calculate here? Probability that the time taken to complete the task differs from the mean by less than 15 minutes. In the last case, you would be finding this probability. What's the mean? Mean is 32.2. 15 units on the left side, that will give you 17.2. 15 units on the right side, that's 47.2. In the last part, you would be finding this probability. Probability of X being between 17.2 and 47.2. Right? You convert it to Z and find that area using the normal distribution table. The rest you can figure out, right? That's simple normal distribution after this. But this is the probability that you would be looking for here. Keep that in mind. Okay. And you can do this after this. All right, so nobody asked about this, so I'll just skip this. Right? Yeah. Okay. Question number 7. Okay, let me explain this again. Read the question statement again. It says, the time taken differs from the mean by less than 15 minutes. The difference from mean. Differs from the mean means the difference from mean, that has to be less than 15. What's the mean? We know that the mean is 32.2. This is the mean. Difference from mean should be less than 15. On the left side, if you subtract 15, you get 17.2. On the right side, if you add 15, you get 47.2. So if you are between 17.2 and 47.2, that makes the difference less than 15 minutes. Okay. Okay, good. All right. Now let's move on to the next one. Question number 7. What's the problem with this? It's a cumulative frequency graph in the first part. Then you have to use the graph to estimate the interquartile range. Then calculate estimates of the mean and standard deviation of the distances. Okay, so I assume it's the last part that you're asking about for this question, right? First two are pretty straightforward. Drawing a cumulative frequency curve and then finding interquartile range using the graph. You can do that. Okay, let's do part C of this. Now in part C, they ask about estimates of the mean and standard deviation of this data from this data. Now you see, this is the table that you're given. How do you find mean and standard deviation from this table? What's the formula that you got for mean and standard deviation? For group data, the mean formula looks like this: sigma xf over sigma f. That's the mean formula. The standard deviation formula is sigma x squared over n minus x bar. Sorry, for group data, it's, why is this not working? For group data, it's sigma x squared f over sigma f minus x bar whole squared and square root of that. Now, for using this formula, you need two things. You need x and f, and then using them, you can find sigma x f, sigma x squared f, sigma f, and all of that. The problem is we don't have frequencies here, and we do not even know what the values of x are going to be. Sorry. This. Okay. We do not have x values, we do not have frequencies. So what we have to do is we have to convert this table, which is a cumulative frequency table, to a normal table first of all, so that we have x for using in this formula and frequency. Right now we've got cumulative frequencies. That's not what we need. X is going to be x is generally the midpoint of intervals. We don't even have the intervals right now. So first of all, we have to find those intervals. Now we're talking about distance. Less than equal to 200. What does that mean? Distance has to be either 0 or positive. It can't be negative, right? So the first interval would look like this: 0 to 200. What's the frequency of this interval? It's 16. 0 to 200, we've got 16 frequency. And then the next interval is going to be from 200 to 300, right? We are converting it to normal table. In normal tables, we have two-sided intervals like this. So we say, in this case, we've got 200 to 300. And then the next interval would be 300 to 500, and then 500 to 900, and then 900 to 1200, and then 1200 to 1600. All right. Now we need to find the corresponding frequencies. If between 0 to 200, we've got 16. This 46 is the cumulative frequency. That means everything from the left side. That means all of this from 0 to 300, that is 46. What is this part going to be then? From 200 to 300. What's this part going to be? 46 minus 16. So frequency here is 30. And then for the next column, 88 minus 46. What's that? 42. And then 122 minus 88. 34. 134 minus 122, that's 12. And then 140 minus 134, that's 6. These are the frequencies that you've got. Once you've got the frequencies, and these intervals, now you can find x as well. X is supposed to be the midpoint of these intervals, right? 0 to 200. What's x? Midpoint of 0 to 200, that's 100. And then you have 250, and then 400, 700, 1050, and 1400. These will be the values of x that you use. And these will be the frequencies. Now, everything else works the same way. What you do is you find sigma f from here, then you add another row to the data, xf, add another row to the data, x squared f, populate these rows, find sigma xf, and then find sigma x squared f, and then you can find the mean and the standard deviation using these formulas. So it's formulas. So the main thing is, the key thing is converting it to a normal table. The rest you can do after that using simple formulas. Is that okay? Make sense? All right, good. Now let's move on to the next paper then. These were all the difficult parts from this question paper. I think the rest of it is pretty straightforward. Remember, we're doing part C here, right? We were calculating estimate for the mean and standard deviation. That's how you would do it. All right, now let's move on to the next paper then. That's November 2021, paper 5, variant 3. That's the next one that we want to do now. Again, make sure that you've responded to the polls already. If you haven't yet, please have a look at the papers and let me know the questions that you find difficult, so we could discuss those questions from these papers. This is now November 21, paper 5.3. That's the other paper that we want to do now. Okay, November 21, paper 5.3. Please have a look at the poll, look at the paper as well. Let me know the questions that you find difficult so we can have a look at those questions in particular. So I'll give you 30 seconds to do that quickly. If you haven't already, then we start with this paper. Ali, can you remind me about that at the end? That alternative method that you were asking about? We could think of it another way. You can suggest maybe something else, and we can try to fine tune that, why it's not working and how we could correct that. We can discuss that at the end, right? For the permutation question, I think you asked about that. Okay, let's have a look at this other paper now. November 21, paper 5, grade 3. So let's look at the, yeah, remind me about that at the end. If you have another method in mind, you can suggest that. And if it's not working for you, we could try to correct that somehow. And I can tell you exactly what you might be doing wrong. So we could correct that together then. If you're trying to do it another way and that's not working, we could see what the problem is. Okay, November 21, paper 5, reading 3. So from this paper, you're mainly asking about questions 5, 6, and 7, right? Okay, now let me just quickly go through this as well. Okay, that's 2-mark question, the first one. We have back-to-back stem in the interquartile range. Remember, just a reminder again, this is ungrouped data. For ungrouped data, you have to use that method for interquartile range. Find the median, and then median divides your data into 2 parts, left side, right side. You find the medians of those 2 parts, and they will give you lower quartile and upper quartile. Do not use these formulas here, or even n plus 1 or 3, n plus 1 over 4. They will sometimes work, but sometimes they will not. So they're not reliable. For ungrouped data, they're not reliable. Please don't use them here. Okay. All right. Now, Question number. That's for more than 43.2, less than 43.2. Question number 4 is not that difficult. It's simple normal, the first two problems. Then you have inverse normal. That's also a simple case of inverse normal. It should not be difficult if you understand the concept well. It should be doable. Okay, so this is the first one that most of you are asking about. Question number 5 from this paper. Let's try this. It says a security code consists of 2 letters followed by a 4-digit number. The letters are chosen from A, B, C, D, E, and the digits are chosen from 1, 2, 3, 4, 5, 7. So you've got 5 letters and 7 numbers, 7 digits. No letter or digit may appear more than once. So you can't have repetitions, right? An example of a code is this. How many different codes can be formed? How do you find that? You need 2 letters and 4 numbers. How many letters do we have in total? 5 letters. Out of those 5 letters, we need to arrange 2 letters in these first 2 places. And the numbers have to be arranged separately, right? It tells you that. It says you have 2 letters in the beginning. So letters have to be arranged separately. So we do 5p2 for that. And the numbers, the digits have to be arranged separately. They have to come afterwards. Out of 7, we have to arrange how many? 4. So that's 5p2 multiplied by 7p4, and that should give you the result. You can see what that is. 5p2 into 7p4. Oh, so that turns out to be 16,800. First part was fairly straightforward. Now it says find the number of codes that include the letter A or the digit 5 or both. Either A or 5 or both. Okay, so how do we think about this now? Now, there are 2 ways of thinking about this. One possibility could be you could say you have A and 5. Either A is selected and 5 is not selected, or A is not selected and 5 is selected, or both are selected. You could consider these 3 cases. Or a quicker way could be that you think of this last case where both of them are not selected. These are the ones that you want. The last one is the one that you do not want, but none of them are there. Okay? It's easier to find this case and subtract this from the total. Okay? That's going to be quicker. You can do it the other way as well. You can also find these 3 cases separately and then add them up together. So you can do it either way. Now, since you know the total already, that's 16,800. Let's consider this case when both A and 5 are not selected. Now, what does that mean? We have 5 letters in total. Out of them, we had to select 2. But if A does not have to be selected, that means we only have 4 options there. Out of 4, we have to arrange 2. And 5 also cannot be selected. So out of the 6 numbers, we have to arrange 4. So that's 6p4. So this last case where both A and 5 are not selected, let's see what that is. 4p2 into 6p4. That is giving me 4320. Now subtract from the total in this case, total minus both A and 5 not included. That will be 16,800 minus 4320, and that should give you the result. That's 12,480. That's what we were looking for. Okay. Make sense? Part B. Let's move on. Now it says a security code is formed at random. Find the probability that the code is DE followed by a number between 4,500 and 5,000. Now the code is formed randomly. There's no condition. That means the denominator is going to be 16,800. Right? Probability, we could define probability as number of favorable outcomes divided by the total number of outcomes. The total number of outcomes is 16,800. So that will be your denominator. What about the favorable outcomes? Favorable outcomes are going to be when this condition is met. So it should be DE. Okay, so the letters selected have to be DE. So we don't have to select letters anymore. It's just about the numbers. What are the numbers? 1, 2, 3, 4, 5, 6, 7. These are 7 numbers that we've got. Okay. Now, what does this become? DE. And then we need 4 digits. We can have 4 boxes for that. We have 4 places. These 4 places need to be filled in a way such that the number is between 4,500 and 5,000. Now, how many options do we have for the first box? If the number is supposed to be between 4,500 and 5,000, the first box has to be a 4. There's no other possibility. If it's 5, the number will be greater than 5,000. If it's 3 or anything less, the number will be less than 4,000 or 4,500. So the first number has to be a 4. There's no other possibility there. What about the second number? The second number could be one of these 3 numbers, 5, 6, or 7. Is there a 0 as well? No, there's no 0. 1, 2, 3, 4, 5, 7. There's no 0 there. The second number could be one of these 3 numbers. Okay. So for the number to be between 4,500 and 5,000, the second number has to be either a 5 or a 6 or a 7. How many options do we have here? We've got 3 options. There are 3 ways of filling the second box. There was only one way of filling the first box, so that's 1 into 3. What about the next box now? Now that we have filled 2 boxes, we have one number in the first box, another number in the second box. The numbers cannot be repeated. How many options do we have for the next one? 5 options for the next one, right? Because we had 7 numbers, we have used up 2 of them already. We have 5 left. And then for the next one, we have 4 left. And that gives you the result. You can see what that is. 20 into 3, that turns out to be 60. Okay. And now what's the probability? 60 is the number of favorable outcomes divided by the total number of outcomes. That was 16,800. And that should give you the result. You can see what this is. That's 1 over 280. Or you can write this in decimals as well. That's the probability that you get in the last place. So then there's a saying between 4,500 and 5,000, right? So you have to be between these 2 numbers. But you do not need zeros for that, because 4, 5, 2, 1, for instance, is between 4,500 and 5,000. It does not necessarily have to be 4,500 or 5,000. Okay, so we don't need zeros for that. All right, so that's the probability. That's part C. Make sense? No problems? Okay, good. Let's look at the next one. That was a relatively easier permutation question. Okay, so what's the next one that we've asked about? 6 and 7. Okay, let's have a look at these questions quickly as well now. In a game, Jim throws 3 darts at a board. I thought we had Jims here. Jim throws 3 darts at a board. This is called a turn. Okay. In one turn, he's throwing 3 darts. The center of the board is called the bullseye. The random variable x is the number of darts in a turn that hit the bullseye. The probability distribution of x is given in the following table. It's given that expected value of x is 0.55. Find the values of p and q. That should be pretty straightforward, right? These are probabilities. The sum of probabilities has to be 1. So 0.6 plus p plus q plus 0.05, that has to be 1. Right? Because these are all possible outcomes given and the probabilities given. The total probability is equal to 1. And now, then you're also given that the expected value of x is 0.55. How do you find expected value of x? From a probability distribution table, it's sigma xp. Let's find xp here. That's 0, p, 2q, 0.15. What's sigma xp going to be? P plus 2q plus 0.15, that equals 0.55. You've got 2 equations, solve them simultaneously, and you would get the values of p and q. All right, that's all that you have to do in the first part. So you get p plus 2q equals 0.4, and p plus q equals 1 minus 0.05 minus 0.6, and that's given me 0.35. You can use substitution, elimination, whatever you want. 0.4 minus 2q, if I put this here, I get 0.4 minus 2q plus q equals 0.35. And that gives me q equal to 0.05. Put this back in the other equation. You get p equal to 0.4 minus 2 into 0.05. That will be 0.3. The value of p is 0.3 and the value of q is 0.05. That's the first part, really straightforward. In the second part, they ask you to find the variance of x. Just apply the variance formula. What's the variance formula? Variance of x is given by sigma x square p minus expected value of x whole squared. Add another row to the data that represents x square p. You can multiply this number and this number for that. X into xp, that's x square p. You get 0. P into p. Now that we know the value for p, write like this for now. P squared, and then 2q squared, and 0.05 into 0.15. 0.0075. Okay. So variance is sigma x square p. Let's add all of them up. What does that give us? P squared plus 2q squared plus 0.0075 minus expected value of x, that's 0.55, square of that. Input the values of p and q. P is 0.3. 0.3 squared plus 2 into q, which is 0.05, square of that, 0.0075 minus 0.55 squared. Evaluate that, and that's going to give you the variance. All right, that part is also pretty straightforward. Let's figure out what that is. If I'm getting something negative, that is not possible. So there's some mistake that we've done here. X square p. Xp is fine. 0, and then we have p squared, 2q squared, 0.05 into 0.15. That's also fine. P squared plus 2q squared plus 0.0075. minus expected value of x, which is 0.55 squared. That's fine. P was 0.3, right? Then 2 into q squared. Can you spot an error here somewhere? How's it p squared? X squared p. Okay, yeah, you're right about that. How's it p squared? I think we are multiplying the wrong things. Yeah, I'm sorry. Yeah, I'm multiplying the wrong things. This is not correct. So we have to be careful about this. I multiplied this length, this row with this row. You have to multiply this and this. I'm sorry about that. Okay, so it turned out to be negative. Variance cannot be negative. Remember that. Variance is negative. Variance cannot be negative. Okay, I was getting a negative result. That's what tells me that there's something wrong. So if you end up getting a negative value for variance or standard deviation, remember that is not possible. So I was multiplying the wrong rows. Looking at this x, I forgot that this is actually probability, not x. Okay, so x into xp, what's that? That's 0, p, 4q, and 0.45. Sigma x squared p therefore becomes p plus 4q plus 0.45 minus 0.55 squared. Value of p is 0.3. Value of q is 0.05 plus 0.45 minus 0.55 squared. You can evaluate this and see what this turns out. That's 0.6475. Yeah, thank you for that. That's what we get, 0.6475. That's part B of this. Let's move on. Now it says Jim is practicing for a competition and he repeatedly throws 3 darts at the board. Something is happening repeatedly. That should ring a bell, either binomial or geometric. If the probabilities remain constant, it's going to be one of those two distributions. Find the probability that x equals 1 in at least 3 of 12 randomly chosen terms. At least 3 successes. What's that distribution? Binomial distribution. Probabilities also remain constant, right? Every single time he throws the darts, the probabilities, okay, they do not remain constant. Do they remain constant? Let me think about it. One time he throws 3 darts, the probability of getting bullseye on those 3 darts is distributed like this. But when you repeat this process, yeah, so he's repeating throwing 3 darts, right? So every single time he throws 3 darts, these probabilities remain constant. Every single time he throws 3 darts at the same time, these are the probabilities that he has, okay, for getting bullseye. So the probabilities do remain constant. Something is happening repeatedly. So this is binomial distribution. What's n? How many times is he doing that? 12 turns. That means n is 12. We need to find the probability that x is equal to 1. So this is what we're calling a success. Success is whatever is the thing that you're finding the probability for. X equals 1, you're finding the probability for x being equal to 1. That's the criteria for success. What's the probability of success then? It's P, which is 0.3. What's the probability of failure? 0.7. We want at least 3 successes out of 12. So the probability that we're looking for is probability of x greater than or equal to 3. At least 3 successes, x greater than or equal to 3. Now this is binomial. We can't find this directly. We have to add each of these probabilities separately. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a lot of probabilities. You reverse this. You say this is the same thing as saying 1 minus probability of x less than 3. That means 1 minus probability of x equals 0 and x equals 1 and x equals 2. If you subtract these 3 cases from 1, you would get that probability that you're looking for. Now this is binomial. What's the formula that we brought for that? NCR p raised to power r into q raised to power n minus r. What do we get from that? 1 minus 12C0 into 0.3 raised to power 0 into 0.7 raised to power 12 minus 12C1 into 0.3 raised to power 1 into 0.7 raised to power 11 minus 12C2 into 0.3 raised to power 2 into 0.7 raised to power 10. Evaluate this and see what that gives you. Okay. 1 minus 12C0, 0.3 raised to power 0 into 0.7 raised to power 12, C1, 0.3 and 12C2, 0.3 squared, 0.7 raised to power 10. Okay, so that should give you 0.747. This probability is 0.747, and that is what we were looking for. Okay, again, simple binomial distribution. Okay, find the probability that Jim first succeeds. First success, again, a keyword for geometric distribution. When does the first success come? Right? Find the probability that he first succeeds in hitting the bullseye with all three darts. With all three darts. This is the criteria for success. Bullseye with all three darts. On his 9th turn, first success. What's the criteria for success? All three darts are bullseye. That's 0.05 probability. Probability of success is 0.05. Probability of failure is 1 minus this. That's 0.95. You want first success on the 9th attempt. What's the formula for geometric distribution? It's q raised to power r minus 1 times p. Q is 0.95, 0.95 raised to power 9 minus 1, that is 8 into 0.05. And that should give you the result. You can see what that is. Okay, 0.95 raised to power 8 into 0.05. That turns out to be 0.0332. Okay, that's the probability that we've got. Okay, that was part D of this. Now, this is the next one that we're asking about. Question number 7. Let's have a look at this last question. Now, it says box A contains 6 red balls, box B. Box A contains 6 red balls and 4 blue balls. Box B contains X red balls and 9 blue balls. A contains 6 red and 4 blue. B contains X red and 9 blue. A ball is chosen at random from box A and placed in box B. A ball is then chosen at random from box B. Complete the tree diagram below given the remaining 4 probabilities in terms of X. Now, think about the situation first. You have 2 boxes. You have box A and box B. Box A, box B. How many balls does the first box have? 6 red and 4 blue. That's box A. You first have to take out a ball from box A. The probability of taking out a red ball is 6 out of 10. Probability of taking a blue ball is 4 out of 10. That's understandable. What about the second box? Box B has X red balls and 9 blue balls. Now, if you take out a red ball from the first box and put that in the second box, what's the number of red balls now in the second box? It's X plus 1, right? Because you took out 1 red ball from box A and put that here. The number of red balls in the second box will increase by 1. So it becomes X plus 1. So you have X plus 1 red balls in the second box now. What's the probability of taking out a red ball from the second box now? It's X plus 1 divided by What's the total? X plus 1 plus 9, that is x plus 10. That's the total. So it's x plus 1 over x plus 10. What's the probability of taking out a blue ball in this case? That's 9 out of x plus 10. And then the second case. If you take out a blue ball the first time, if the first ball taken from box A is a blue ball, you had x red balls initially, they remain x. The number of blue balls increases by 1. The number of blue balls is now going to be 9 plus 1, that's 10 blue balls. The total is still x plus 10. So now the probability of selecting a red ball would be x over x plus 10. And the probability of selecting a blue ball would be 10 over x plus 10. That is what your tree diagram looks like in the first part. Okay. This is what you get. Now it says, show that the probability that both balls chosen are blue is 4 over x plus 10. Both chosen are blue. What does that mean? You have blue the first time and blue the second time. Just multiply those two. 4 over 10 into 10 over x plus 10. 10 and 10 get cancelled. And you have 4 over x plus 10. That's the second part. Fairly straightforward once you have the tree diagram there. Okay. And then part C of this, it's given that the probability that both balls chosen are blue is 1 over 6. Okay. Probability that both balls chosen are blue, that is 1 out of 6. That's the probability that we found in the previous part. They are saying that this probability was supposed to be 1 out of 6. Find the probability, correct 3 significant figures, that the ball chosen from box A is red, given that the ball chosen from box B is red. Now, using this, what you can actually do is you can find the value of x first of all, right? You know that the probability of getting 2 blue balls, that is 4 over x plus 10. And now they're saying that's actually equal to 1 out of 6. You get an equation from this that you can use to find the value of x. Let's cross multiply. It gives you 24 equals x plus 10, and the value of x turns out to be 14. So now you know the total the number of red balls in the second box is 14. Okay, so now it's something like this. Box A and box B. A had 6 red and 4 blue. Now B has 4 red and 9 blue. That's the starting, that's the initial stage, okay? All right, now find the probability that the ball chosen from box A is red. Probability that ball chosen from box A is red, I'm saying AR. You can say red ball from box A, RA, given that the ball chosen from box B is red. This is the probability that we want to find out. Now, what does that mean? In the denominator, you have the probability of what is given. What's given? That the probability that the ball chosen from box B is red. That is what is given. That's what you have in the denominator. In the numerator, you have the probability of both of those conditions being true, that the ball chosen from box A is red, and at the same time, the ball chosen from box B is also red. In the numerator, you want both conditions to be met, intersection of both of those cases. Now, what's the probability of the ball chosen from box B being red? The denominator. B can be red in either this case or this case. Okay. Now, what we can actually do is, to make things simpler and not do calculations in terms of x, we can make another tree diagram. It's a, right, I'll just do it here again. That will make things a lot simpler for you. So make another tree diagram where you have the values input for x. You have red, blue, red, blue, red, blue. What was the probability for the first time? 6/10 and 4/10. The second time, for red, it was x plus 1/x+10. Now we know x is 14, x plus 1, that is 15/24. And then this would be 24 minus 15, that's 9/24. 9/14 plus 10, that's 9/24. And you have x/x+10, x is 14. So this is going to be 14/x plus 10, that's 24. And then the remaining would be 10/24. This is the tree diagram that you have now. What's the probability of getting a red ball from box B? Red ball from box B. I have to be more clear here, otherwise A and B are kind of using as well. Red ball from box A and red ball from box B, right? That's what we're saying. R and B are representing red and blue balls here, but these are representing the boxes, okay? A and B boxes. I hope that is clear, okay? What's the probability that you get a red ball from box B? This was the first box. This is box A and this is box B. Red ball from box B. That's this case or this case. What are the probabilities for them? Red, red or blue, red? That's the denominator. What would you have in the denominator? These two cases. 6/10 into 15/24. What does that give you? 6 into 15 divided by 240. That's giving me 3/8. And this one is 4/10 into 14/24. What does that give us? 4 into 14 divided by 240. And that's 7/30. The denominator is both of these cases. So in the denominator, we have 3/8 plus 7/30. This is the total probability of the ball from the second box, ball from box B being red, right? And then what about the numerator? Red ball from box A and red ball from box B. That's this case. Both red, 3/8. That is going to be your numerator. And that should give you the result. 3/8 divided by 3/8 plus 7/30. And that's giving me 45/73. That's the conditional probability that we were looking for. Make sense? All right, and that completes this paper as well. I hope that was helpful. For permutation and combination questions, well, what you have to do is make sure that you know all the standard methods. You should know how to do arrangements when you have repetitions. You should know how to do arrangements when you want to have some objects together, have some objects separated. You should know the total minus together method. You should know the dashes and stars method. So you need to know those methods. And then you need to understand how to use permutation notation, NPR notation, when to use that, when to use factorial notation, when to use combination notation, right? Understand all of those scenarios. understand how to make cases for combination questions, and understand uh, the different kinds of problems that you get in combinations. You get the hang of it when you do a lot of practice. So once you're done with these standard concepts, then you have to do. So I'm not sure if that's possible for you now, but by now, since you started, you should have attempted at least like 70-80% of permutation combinations. That's how you do permutation combinations. A lot of practice, because you learn the different kinds of ways of approaching problems by doing a lot of problems, and that helps you develop your logical thinking ability as well. That helps you in the exam when you end up getting something that you've not seen before. So how do you figure that out? Once you've done a lot of practice, that is what is going to help you in the exam. So ideally, you should have attempted like 70-80 questions by now. But now, in the remaining time, depending on what your timetable looks like, do as many as possible. Make sure to do the recent questions in particular, because there are some kinds of questions that are getting repeated, right? So, for example, one question that we did in the earlier paper right now, paper 5.2, where we had where we had two letters, and then we need to have two letters between those two letters. This is kind of a repeated theme that you will find in the recent papers. And there's some other things as well. There's some problems in which you have to you have combinations involved along with probability, and there's repetition. There's a specific method that we use for that you need to know about. So there's some questions that are kind of getting repeated in recent papers. So you need to make sure that you are done with the last 3-4 years of papers in particular. That's important. I'm not sure about what's going to happen with P1. Most likely and hopefully a retake. I hope they don't go with assessed grades, but I think it has to be one of the two, either assessed or retake. They can't just ignore it, because I think it's pretty clear that it was beat. So just pray that I would say it's better for everyone that we have a retake, because assessed grades like last year, they are going to be a mess. Last year, people who had A's or B's in the papers that they gave, they got B's or C's assessed in the remaining papers that they did not give. So basically, in the other papers that they did not appear for, the grades were downgraded for some reason. So assessed grades are not going to work out for everyone. So I think the best option would be that we end up having a retake. But let's see. We can just wait now. There's no other possibility that we have. Okay, all right. So that's it. If there are no other questions from this paper, we will be stopping here. Now, Dilmi, you can let me know the question that you had. And Ali, if you're here, no. Okay, so Dilmi, you can let me know the question that you were asking about. We could discuss that one quickly, and then we end for today. Dilmi, are you there? Oh, okay. Okay, so you send it to me on WhatsApp. All right, let me have a look at that. Okay, it's downloading for me. This might take a minute or so. Okay, it's not a past paper question, but okay. Let's have a look at this. Share this. I can't send it for some reason, let me try again. Yeah, I'm just trying to forward it to me myself on iPad, but it's not working out for me. Okay, I think I'll just write it down because I can't send it to myself for some reason right now. Let me just write that down. So you were saying, this thing here. Okay, so you are given something like this: x, it follows binomial distribution, n is 10 and p is 0.3. So it's a binomial distribution with n 10 and p 0.3. Okay, that's what you're given. You need to find expected value effects and variance effects. So you're not, don't have a problem with the first part, right? It's only the second part that you're asking about. Okay, now the second part is find the probability of x being between mu minus sigma and mu plus sigma. This is what you want to find out, right? Now, what's the answer to the first part? Expected value and variance. You should have found that already, right? Can you tell me those results? Well, let me ask you it right now. Mu is n times p, right? For binomial, that's 10 into 0.3. That should be 3. What about standard deviation? That's npq. That will be 10 into 0.3 into 0.7. And square root of that, what does that give us? 10 into 0.3 into 0.7. Square root of that, that's 1.45. Roughly, that's what you're getting. Okay. Yeah. Now we need to find the probability that x is between mu minus sigma. That means 3 minus 1.45 and 3 plus 1.45. Right? This is what we're looking for. Mean is known, that's 3. Sigma is this, 1.45. What does that give us? 1.55. That's less than x, which is less than 4.45. Now, x is binomially distributed. That means it's a discrete variable. It can only have integer values. In this case, binomial is supposed to have integer values. What values of x are possible between these two numbers? X can either be 2, or it can be 3, or it can be 4. We'll just apply the formula NCR p raised to power r into q raised to power n minus r. Let's say n was 10. That's 10c2 into 0.3 raised to power 2 into 0.7 raised to power 8, sorry, plus 10c3 into 0.3 raised to power 3 into 0.7 raised to power 7 plus 10c4 into 0.3 raised to the power 4 into 0.7 raised to the power 6. That's what you get. Yeah, it's binomial distribution. So for that reason, we have to take integer values only. Right? It's binomial distribution. It's not normal. So don't get confused by this notation, because you have seen this notation more in normal distribution, but this is supposed to be binomial, right? That's what it says. It's binomial distribution. You have to use that. Okay. And these are supposed to be integers. All right, good. So that's it then. I'll see you again in the next class. That's all that we had to do for today. We're not done with November 21, paper 5.2 and paper 5.3. Paper 5.1, you already have the recording available for that. It's solved fully. All questions are solved. So I'm not going to go. I'm not going to do that. The next papers that we will do will be from June 2021. All right. Difficult questions from 2 June 21 papers. All right. So that's it for today. I'll see you again in the next class. Allah Hafiz.